In this video, I will be covering the operation of the Sres cone drill. First thing we need to do is attach the drill to the tractor. Make sure to follow all safety protocols when installing the drill onto the tractor. Then we want to raise the drill up and lift the toolbar stands and pin them into planting position. Follow the same steps on the other side of the drill as well. Connect the power connector on the drill to the supplied heavy gauge cable. The cable should be connected directly to the tractor's battery. Now we can set the drill down and level the toolbar. When planting, we want the toolbar to be parallel with the ground. We level the toolbar by adjusting the top link of the tractor and the ground wheels of the drill. If the drill is equipped with Great Plains openers, the down pressure is adjusted here. This style of opener uses the press wheel to adjust planting depth. Moving this adjuster forward plants shallower, and moving it back plants deeper. If the drill is equipped with this style of coulters, there are jacks on both sides to adjust their depth. Then we turn on our main electrical power. Hold the button in for it to stay on. All Sres cone drills are controlled by a programmable logic controller, or PLC. This is our ready screen, which is what we will be in when we're planting. On the left we have our plot progress bar that will move towards the top as we advance through the plot. Over to the right we have a speed indicator bar that will show how fast we're going. Down below we have our left, right, up and down buttons for going through our menus. Pressing the right arrow button will take us to our plot setup menu. In our plot setup menu we have three selections. The first thing we have is auto trip. When we have this set to on, the planter will automatically cycle when it travels the plot length. In this example, it will cycle every 120 inches. If we're using any other method to trip the planter, such as GPS, a cable winder, or a check head, we want this set to off. The next setting we have in this menu is our alley length in inches. And then finally we have our center of alley to center of alley measurement. This is where we get our plot length. To change any values in the PLC program, we simply scroll to the value, hit the enter key, use the keypad to change the value, and press the enter key again to save it. This is how we change any values in the PLC program in any of the menus. Pressing the right arrow will take us to our next menu. This is our calibration menu. The first thing we have is our plot length factor. I will show you later on how to set our plot length factor. Then down below it we have our high cone speed and our low cone speed. These are the first settings that we have to set. And I will explain how to set the high cone speed and the low cone speed. We'll pull the cover off the cone and put a mark at a fixed reference point on the cone. Then we'll press the F1, the high cone speed, and hold that down for 1 minute. And then we just count the revolutions of the cone in that 1 minute time. When the cone stops spinning after 1 minute, we find out exactly how many RPMs the cone is spinning, and we enter this value into the PLC for our high cone speed. Then we'll repeat this process by holding down the F2 button for 1 minute and get the low cone speed and enter that into the PLC. Pressing our right arrow key again gets us to our next menu. This menu here is for adjusting multiple cones to spin the same speed on one planter. These are preset at the factory, and if any changes need made in the field, contact an Sres technician and we'll talk you through how to make these changes. Pressing the right directional button again will take us back to the ready screen, unless your machine is equipped with a leveling system. If it is equipped with a leveling system, we press F1 to calibrate the system. Then we use the directional buttons to move the cone until it is level with the bubble level indicator. Pressing F2 saves the calibration. Now we can set the last setting in the calibration menu, the plot length factor. So we will take the drill out to the field, and with the row unit slightly off the ground, we will run a few plots through the drill, and then we can get some plot lengths. While we're planting, we'll notice the plot progress bar to the left, the speed indicator bar to the right. Up here we'll display the last plot length, and below the last plot time. Now we measure from the first seed of one plot to the first seed of the next plot for several plots to get an average COA to COA, or center of valley to center of valley. So now we take the average COA to COA that we found in our test and divide by the COA to COA currently in the PLC. For example, if you have a COA to COA of 120 inches in the PLC, but your average COA to COA planted is 125 inches, we divide 125 divided by 120 to get 1.0416. Now multiply the current plot length factor by 1.0416 to get a new plot length factor. Now, with our current plot length factor of 24.2 multiplied by 1.0416, this yields us a new plot length factor of 25.2. So we can go back to our calibration menu and enter our new plot length factor and run the test again and remeasure our plots. The last thing I will be covering in this video is how to line up our plots and line up our alleys. The SRES cone drill uses an electrically driven spinning divider to divide the seeds evenly amongst the row units. It takes time for the seeds to go from the divider down to the row units, so we need to do some testing to determine our setback. With our main power turned on, we are ready to drop our first packet of seeds into the funnel and press the cycle button. This will lift the cup and drop the seeds into the cone. Pressing the cycle button also resets the plot progress bar and the plot timer. Put a reference line on the ground that matches a spot on the drill. In this case, I'm using the center of the axle. And then drive the drill through one plot and record where the first seeds fall. The difference between our reference line and our first seeds is our planter setback. In our test, our setback was 32 inches, so we want to plant another plot with the drill 32 inches further back than we did in our previous test. This should have our seeds coming out exactly where we want them. Then at the end of the plot, we will check where our last seed is, and on our return pass, make sure the drill is set down at the setback distance past our last seed. The setback will vary with different drills, and it will also vary if we change speeds. So if we change speeds, we have to run the test again to get a new setback number. Here are some examples of what our plots would look like in the field with too much setback and not enough setback, with the yellow indicating the direction of planting. Thanks for watching.